Welcome to The Explainer. Today, we're unpacking a really high-end concept within the energetic paradigm, or EP for short, called semantic compression. Now listen, we are not talking about some basic summarization tool here, and we're definitely not talking about a decorative funnel just to make text sound prettier. Nope. What we're looking at is a disciplined structural converter. Think of it as taking all this complex, messy reality, like dense documents, meeting transcripts, and governance materials, and distilling the whole shebang right down into its absolute most actionable form.
Okay, let's dive into this. We are taking a highly structured, investor-facing walk through the business case for controlled AI work. We'll hit the AI structure problem, formally define semantic compression, and then test its viability through three critical investment lenses: demand, execution, and scalability. Finally, we'll wrap up with the ultimate investable takeaway.
Section 1. The AI structure problem. The illusion of competence.
So, to really understand why semantic compression is absolutely crucial, you first have to recognize a catastrophic flaw in current AI systems. It's what we call the illusion of competence. See, ordinary AI produces these summaries that sound incredibly fluent, right? Great vocabulary, perfect grammar. But honestly, that fluency is dangerous. Why? Because it strips away the underlying structural logic required for actual real-world decision-making. It hides its reasoning and removes critical constraints just to make the text flow better, leaving you with a lossy summary. On the flip side, what the S-Corp enterprise actually needs is structural reliability. We need inspectable proof logic, auditable trails, and true operational intelligence. Relying on style without structure isn't just unhelpful in high-consequence environments, it literally creates a massive institutional liability.
To quote the source material directly here, AI summaries often remove what matters. Investors and operators need compression that preserves decision-relevant structure. I mean, that hits the nail on the head. This is a recurring, heavily expensive failure. When AI moves from casual, everyday chat into serious enterprise work, losing that underlying structure isn't just an annoyance, it's a full-blown critical failure.
Section 2. Defining semantic compression, an enterprise control valve. So how exactly do we solve this? Well, we explicitly transition away from cosmetic writing tools and move toward a rigorous enterprise control function. Formally, semantic compression is an EP function that compresses complex material into the smallest structure that still preserves the claim, the mechanism, the constraint, the failure mode, and the consequence. This is a real game changer. It fundamentally changes how a task is framed long before the answer is even produced, checked, and judged. It stops asking, hey, can the model say something plausible? And starts asking, does this output actually have the structure required to survive in a high-consequence environment?
Now, what's really interesting about this framework is that we are dealing with a precise deductive formula. We're not just hacking away at text to make it shorter. We are actively preserving the 5 critical pillars of operational intelligence. Number 1, the claim being made. 2, the mechanism of how it actually works. 3, the constraints limiting it. 4, the failure modes if things go south. And 5, the ultimate consequences. Following this disciplined approach completely prevents uncontrolled expansion and keeps the output firmly rooted in reality.
Section 3. Demand, the market need. Why mistakes cost money.
We're pivoting now to the first pillar of our investment traction triad, demand. Why does the market desperately need this right now? I'm posing this directly to you. Think about it. Demand shows up when a repeated failure becomes just too expensive to ignore. AI is rapidly moving out of the sandbox, and the cost of uncontrolled, structurally weak generation increases exponentially the deeper you deploy it into an organization.
Think about it like this. A casual chatbot can totally tolerate some loose reasoning. If it gets a movie trivia question slightly wrong, whatever, right? No big deal. But think about legal review and contracts, financial analysis, due diligence, complex enterprise workflows, governance systems, autonomous agents. In these environments, an output is only valuable if it can be trusted, audited, and reused. They absolutely cannot tolerate plausible-sounding noise.
So, the crucial point is this. In serious enterprise deployment, mistakes create real cost, delay, liability, reputational risk, and operational failure. We are not talking about helping someone write a better essay here. We are talking about mitigating severe institutional risk. Buyers desperately need methods that reduce drift and unsupported claims way before they turn into a business disaster.
Section 4. Execution, controlling the work, turning messy input into controlled output.
Moving to our second traction test, we have to look at how the energetic paradigm performs this function repeatedly under pressure. And this brilliantly illustrates what execution actually looks like. When you input an ambiguous proposal, the controlled output gives you a clearer investment structure. Feed it a messy agreement, and hidden contradictions are suddenly exposed. An unstructured workflow, it becomes explicit correction rules, and loose governance is compressed right into defined operational constraints. The reasoning path is made completely inspectable. Outputs are evaluated against strict structure, not just a slick writing style.
Execution is proven when failure isn't just quietly edited away by a human later on. True execution metrics mean the system actively reduces long documents without losing that critical proof logic. It explicitly defines what the system should reject, it evaluates output against strict structure, and most importantly, it classifies failure to actually improve the next execution. That right there is how a messy task becomes a reliable, repeatable operation.
Section 5. Scalability. Repeatable AI modules. Expanding the logic.
We're transitioning to our final traction test now. Scalability. How does semantic compression adapt across an entire enterprise without losing its strict operating logic? Well, it scales by acting as a compression layer across tons of different domains. We're talking document intelligence, executive briefings, enterprise co-pilots, AI governance, agent orchestration, research workflows, and even media production. The really cool part is that while the surface content completely changes from, say, a legal contract to a research paper, the control function remains exactly the same. It's addressing a structural failure that appears repeatedly, everywhere.
Because scalable value comes from repeatable software modules, not isolated consulting brilliance. If you have to rely on one brilliant human to swoop in and fix the AI's mistakes every single time, you don't actually have a product. By turning this control function into templates, checklists, and quality gates, you create a clear, scalable path to productization. It becomes an embedded standard across the enterprise.
Section 6. The investable takeaway. Converting liability into asset. Okay, let's move to our conclusion and see how this builds into our final thesis. We are taking a massive, recurring AI failure, uncontrolled, lossy, merely plausible generation, and converting it directly into a repeatable EP capability. Suddenly, you get work that is controlled, deductive, auditable, and operationally useful. We've shifted from an abstract, dangerous weakness into a highly concrete operating asset.
From recurring failure to repeatable capability. That is the ultimate investor thesis here. Semantic compression isn't just some neat academic idea, it is a vital piece of the infrastructure needed for reliable AI work. It connects a very real, incredibly expensive market pain to an executable method and a highly scalable product logic.
So, I want to leave you with a question to mull over as we wrap up this explainer. Take a close look at your own systems. Are your AI workflows simply generating fluent noise, or are they delivering true operational intelligence? When you prioritize structure over style, you don't just get a summary, you get a reliable, investable asset. Thanks so much for joining me today, and keep questioning the structures behind your intelligence.